This challenge is called Pitter Patter Platters. It's a medium-level challenge from the forensics category from the picoCTF 2020 mini competition. The description says, "Suspicious" is written all over this disk image. Download this disk image over here. Okay, so the first thing we want to do is we want to copy the link for this disk image right here. So we're going to hover over the link and then right-click on it and then select Copy Link Address. After we've done that, we can go over to the web shell, and in the web shell, we're going to create an environment where we can complete this challenge. So in order to do so, for these forensics challenges, these forensics disk image challenges, we can't copy the image over to our home directory because we're not allotted enough disk space to hold these large files. So what we can do is we can create a file, create a directory in the temporary directory to work inside of. So what I'm going to do is I'm going to make a directory inside of the temporary directory called the Shy Hat, so with the triple dots just so nobody can find it, and then we're going to move into that directory to work inside of. So after we've done that, we're going to download the file using wget. So we're going to type wget and then space, and then right-click and paste the file link into the terminal. So after we hit the enter button, we see that this disk image file has been downloaded to our working directory. So if we use the file command on this, it says this is a Linux ext3 file system data file. So what we can do is we can start using some forensics tools from the sleuth kit to see what's up with this file. So I'm going to clear the terminal, and then what we're going to do is we're going to run fls with recursive on the suspicious file system file over here. So fls with the R flag is going to let us see the file system contents of this particular disk image. And after we run it, we see that there's a bunch of different files in here, but there's this suspicious file over here over at inode number 12. So we need the inode number in order to access and use other forensics tools on these files over here. So we've got suspiciousfile.txt, and we want to read that file. So what we're going to do is we're going to use the icat command from the sleuth kit in order to read it. So it's icat and then the name of the image file and then the inode number. In this case, it's 12. So when we run that command, it says nothing to see here, but you may want to look here, and then there's an arrow pointing. So the thing is that we don't know what this is necessarily pointing at, but what we can do is we can get a hex dump of this particular disk image file, and then we can try to look for a particular pattern. So what we're going to do is we're going to run xxd to get a hex dump of the file, and we're going to look for a specific pattern. We're going to pipe that into grep and use -e to supply a pattern, and we're going to look for that arrow. So there is that arrow in the message in suspicious file.txt, and you might want to look here, and then there was an arrow. We're going to look for that arrow inside of the hex dump, and we're going to look at the previous 6 lines that precede that arrow and the following 6 lines that follow after the arrow with the -C argument with grep. So when we run that, we see that there is a flag located right here. So if we go up here, it says nothing to see here, but we might want to look here. And for some reason, inside of the hex dump over here, we have the flag, but the suspicious file was actually pointing to it, but we weren't able to see it until we did a hex dump on the file. So what we can do is we can take a look at the flag, and the flag is actually backwards. So you see the picoCTF, and it's a bit of a pain to try to manually format this so that we can submit this. So what we're going to do is we're going to run another command to format this in a way that that the picoCTF competition will accept. We're going to use this command to output the flag in the format that we want. So xxd is going to run on suspicious.dd.sta1. So that's going to provide a hex dump, which includes the flag text. Next, we're going to grep out the section, which includes the arrow, and we're going to include the next 4 lines after the arrow, which includes the flag text. And then we're going to pipe that into an xxd reverse, which is going to reverse the hex dump and is going to turn it into regular text again. So when we do this, we're going to see the reversed flag over here, but unfortunately something in the code also ends our web shell session, but that's okay, because what we can do is we can copy the reversed flag right over here, and then after we copy it, we're going to reconnect to our web shell, and then after that we're going to output the flag in the in its regular format by echoing out what we just copied between these single quotes over here, and we're going to pipe that into the rev command, which is going to take the flag and it's going to print it out in reverse order. So after we do that, we get the proper flag over here, and all we need to do now to finish the challenge is copy the text, then go back to our picoCTF challenge, and in the flag submission field here, paste in the flag, and click on Submit Flag. And then we're finished.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.